Hello, welcome to TGM tutorials. In this tutorial we'll look at lesson 7, which is inverse of a 3x3 matrix. Let's look at the definition. Let A be a non-singular 3x3 matrix. By non-singular we mean matrix A as a determinant, also as an inverse. Then the inverse of A is equal to 1 over determinant of A over the adjoint multiplied by the adjoint of A. Okay, in the previous lessons we looked at how to find the determinant of a 3x3 matrix. That should be lesson 4 or 3 if I'm not mistaken. So if you haven't watched those lessons, I advise you to go and watch those lessons, and also on how to find the adjoint of A. We did that in the previous lesson. That is lesson 6. So here, if you can see, we have two things involved here on finding the inverse of the matrix. We have the determinant, we also have the adjoint of A. So for you to carry out the inverse of the matrix, you need to find the determinant of the given matrix and also the adjoint of the given matrix. Let's do this activity to find the inverse of this matrix. We have A with entries 1, negative 1, 0, 2, 1, 3, negative 2, 0, and negative 1. So to find the inverse of this matrix, we need first to find the determinant, secondly find the adjoint. By finding the adjoint, we have to first find the minors and the cofactors. Okay, so the determinant of A is equal to 1 multiplied by that matrix. Here we are considering entries in the first row. So if we consider this one, we are taking out the first row and the first column. We remain with this matrix, and that is the one we have here. Minus negative 1. If we take out the column, second column and the first row, we are going to remain with that matrix, and 0 as well. The determinant of A is equal to negative 1 plus 4, which will give us 3. Okay, the adjoint of A is giving us negative 1, negative 1, negative 3, negative 4, 1, negative 3, 2, 2, 3. If you are not sure of how this came about, you can just take a piece of paper and start by finding the minors and the cofactors. How to find the minors and the cofactors, we did that in the previous lesson, lesson 6. If you have forgotten, just go back to the lesson, watch the video, and you are good to go. So the inverse of A is equal to 1 over determinant multiplied by the adjoint, and that should give us 1 over 3 multiplied by the adjoint of A, and that is the inverse of A. Okay, now we are going to look at solving system of linear equations using inverse method. Okay, if we let this be a system of 3 linear equations in 3 variables, and if the coefficient matrix A is equal to that is non-singular, then x, y, z is equal to the inverse of this matrix. The inverse, that's why we have a negative 1 here. It represents the inverse of this matrix multiplied by b1, b2, b3, and that's b1, b2, b3. The results here. Okay, and that is equal to, here where we have the inverse of this matrix is this part, because 1 over determinant multiplied by the adjoint of A is the inverse of this part, represents the inverse multiplied by B1 B2, which is this one. Okay, let's look at this activity. I've decided to use the same question, the same activity which I used when solving a system of linear equations using the inverse method. In the previous example, I used this same matrix to find the inverse. So the coefficient matrix is equal to that, as you can see, just the same as the one which I used. So here the inverse of that is equal to that, multiplied by 1, negative 3 and 0, and we are going to have x is equal to, if we multiply this, okay, let's multiply so that you follow how we got to this answer. We have negative 1, this is a 3 by 3, and this is a 3 by 1, so we can multiply this one. If we multiply these two matrices, this and that, the answer should give us a 3 by 1 matrix. Okay, so now we are going to multiply this and that. We have negative 1 multiplied by negative 1 multiplied by 1. We multiply, when multiplying matrices, multiply row by column, row by column. So we have negative 1 multiplied by 1, that should give us a negative 1. Negative 1 multiplied by negative 3, that should give us positive 3, plus 3. Negative 3 multiplied by 0, that should give us 0. Okay, come to the second row. Negative 4 multiplied by 1, that should give us negative 4. Negative 1 multiplied by negative 3, that should give us positive 3. Negative 3 by 0, that should give us 0. To the third row, 2 multiplied by 1, that should give us a 2. And 2 multiplied by negative 3, that should give us negative 6. 3 multiplied by 0, that should give us 0. And that should give us negative 3 plus negative 1 plus 3 plus 0, that should give us 2. Negative 4 plus 3, that should give us negative 1. 2 minus 6, that is negative 4. This, and this is how we are getting this. And if we multiply by 1 over 3, which is the 1 over determinant, we are getting 2 over 3, negative 1 over 3, negative 4 over 3. The value of x is 2 over 3, y is equal to 1 over 3, negative 1 over 3, and z is equal to negative 4 over 3. Thank you for watching this video. If you would like to watch more videos from this channel, just click on the subscription button below and more videos will come your way. Thank you.